Hello and welcome to my Tech Talk. My name is Philipp Kern. I work for Datenkraft. I'm a software engineer there. Datenkraft is a subsidiary from the NICEShops group. And today we'll talk about OAuth 2.0 and JSON Web Tokens. All right, let's get right into it. The first part is OAuth 2.0. What is OAuth 2.0? OAuth 2.0 is stands for Open Authorization version 2.0. And it's a standard for access delegation. For example, you might notice, if you want to log into Google, there you can go to a website, you can sign in with Google. Google, there's the button to go to Google. At Google, you sign in with your credentials, and then you come back to the website and you're signed in with your Google credentials without actually giving access to your Google account to the site. Or we'll go later into this. It's called a client in the OAuth 2.0 flow, without giving him direct access to your password. Or other things, for example, you can do is API access directly, so without user interaction for the authorization. That also, there's a flow defined in OAuth 2.0 for this exactly. And what is for the connection to the Google identity provider? There's also a flow called OpenID Connect, which will not go into this talk, but it's used for single sign-on-esque features. For example, because with a direct single sign-on, you would log in once and be already logged in the other services. But for example, with the Google example from before, you need to click actually to sign in, but you only need to sign in once into your Google account. So that's why I would call it a soft single sign-on flow. Then also what does OAuth 2.0 provide? You can have granular permission given to the service needing it. For example, if you go again to the Google, you can give permissions for your email address or your name, for example, but not your calendar entries. You can give only granular access to specific parts of your data or resources. And also this access can be time restricted. So the service might not be able, for example, to access tomorrow because there's only a 1-day period for access. And this allows to have restricted access for the time and not be able to reuse it. For example, if there's those tokens you get granted from Google, for example, get leaked somewhere, you're not able to reuse them in the future. All right. And then what does OAuth 2.0 exactly specify? So how is it defined? So there's an RFC for all of this, and it defines really the HTTP calls, requests and responses you're doing against the authorization server or the other roles I'll show later on, which are defined. And all of that is really specified directly, and you can read about this. And what does the OAuth 2.0 specification say about the tokens? So those tokens you're getting back, it's just a string. So any character string representing information, so the server using it can understand it, but it does not specify how it's exactly built. So you can put anything you want to. OAuth 2.0 does not specify this. You're just getting a token. So for the client using those tokens, they don't need to understand it. You just need to have it to pass it along to be authorized against, for example, Google. So Google knows who you are. They understand the token because they have issued it before, but you don't. So the client, the application that needs access to, for example, your username, does not need to know how the token is built. And also how is this token transmitted? Usually there's a definition. Also there's an RFC for OAuth 2.0. It's a part of it. It's the bearer token. For example, this is goes into the header of a request where just this token you're getting from Google is in, and you put it in all the requests you want to have where authorization is required. So that's a token. Also, you can do it in the post body. That's also defined, but usually the authorization header is the way to go. And we've talked about before, for example, the access for the username and email address, but not calendar or any other data you have in your Google account. And this granularity is called scopes in OAuth 2.0. So you're having scopes. Scopes define really permissions, however they are defined. So again, OpenAPI 2.0 does not OAuth 2.0 does not specify the scopes. The service providing them says which one is there, because there is no reason, for example, to have a calendar access scope for a service which does not provide calendar data. So that's not specified. All right, so I've talked about some roles here, so let's go directly into them. The first role is then the resource server. So who is the resource server? The resource server is the one who has the data. For example, a Google server having your calendar data, for example, or your username. It has the data, but it doesn't know who you are or who wants to access. So it needs to know, do you have access to this data? And for that, first we go into who is the one who has the data, who owns the data. I mean, that's the resource owner. The resource owner is the one actually owning the data. So for example, your calendar entries, that's your data. It's not stored on your system or your server. The resource server stores this, but you are the owner of it. And and then the next part of the role is the client. So, and who is the client? The client is just any web application, for example, or a mobile app, or any desktop application wanting access to your data. So they are called the client in the OAuth 2.0 specification, and they want access. And the last part is, because we've talked, there is a token you need to pass to the resource server. So how do you get this token? And this token is fetched from the from the authorization server. And that authorization server is the one you're providing, for example, your login credentials to get an actual token. And that token is issued by the authorization server. And this authorization server might be the same server as the resource server, or might be a different one. For example, smaller systems could combine those two, but for example, if you have microservice architecture, you could have a central authorization server only doing the authorization part, and then the individual resource servers just getting this token and understanding it and using it to know what you can do. And then, so OAuth 2.0 has, so how do you get this token, rather? OAuth 2.0 defines for this grants, they are called. And there are three main grants which are recommended. I'll read them out loud shortly. There's authorization code grant with the PKCE, it's called, PKCE extension. I'll talk about this in a while. And then there's the client credentials grant, and then the refresh token grant to actually, for example, if a token expires, you need to get a new one. That's defined in the specification as well. And just to have heard about them, there are some legacy grants. The authorization code is still used, but the PKCE extension is recommended. So the authorization code grant there's the implicit grant and the password grant. Especially the later two are not recommended because there have been some security flaws have been found in those. So no recommendation there. All right, then let's go into the first one. That's the authorization code grant with PKCE. So it's really, what does PKCE stand for? It stands for, hold on. It stands for Proof Key for Code Exchange. And that's so let's talk about this grant. First, the application, so the client we've talked about, it's called, wants to access your data. So how can, and they want to authorize against Google. How do they do this? First, the client registers with Google, so Google knows about them. And Google gives them a client ID in the secret. And additional data you can give to Google, for example, a logo or some name. So when the user clicks on sign in with Google, they go to Google, then there is shown, for example, this is a NICEShops login with a NICEShops logo, for example. That's known beforehand, so the client is registered with the authorization server. Again, I'm taking the Google example here. And then you go to the website who wants to log in with your account and get your data. They redirect you to Google. And on that part, and that's the PKCE extension, they define a code challenge. And what is a code challenge? Code challenge is a hash of a code verifier. And this verifier could be any string. So the client defines this. For example, ISDF, and that's not very secure, but ISDF, that's hashed. And then that code challenge is then passed to Google. additional what's passed, so that's part of the original authorization code grant, is a redirect URL. So if the user goes to Google, logs in there, and comes back, the system, or the Google rather, needs to know how it can go back. So there needs to be a redirect URI to get back to Google, to our client. And here's also a security consideration. This redirect URI is registered beforehand with Google, so there is no malicious possibility to switch this out and have another URI and go back to another service, for example. Usually that's why if you register with a system, an authorization server, they ask you to give a redirect URI, at least the base part of it, beforehand, before you can use it. All right then. So we're on Google, on Google side. So that one example for an advantage with OAuth 2.0 is you can log in at Google, and Google, for example, can do things like two-factor authorization, can do biometric checks, for example, whatever they do. A second factor, for example, additionally to the password, is there possible, and they can have their own security measures for that. And we don't need to know about this data. Our client doesn't need to know what's there, how is the authentication part in this case done. We're only getting back then with a redirect and a authorization code from the Google server. And with this authorization code, we can then trade in again against the authorization server. That's the second part. We can trade in against an access token. So, and when we get this access token, the Google server checks if the code verifier we are passing when getting the access token matches the code challenge hash. So that's the hash of the verifier we have put before to Google, matches that with this trade-in for the access token. And so that's what this protects against this. For example, if you have a mobile app, you're clicking login, and in your app you click on login with Google, you go to Google, then come back. There is no guarantee that you're coming back to exactly the same app, for example. So there might be a malicious actor in between and, like say, hijack this connection, and then they can trade in the token. And that's why there's the code verifier, and this code verifier is stored in your client, and anybody getting that response does not know the code verifier, so they can't do the actual trade-in later on with Google and get the actual access token. So that's what the PXE extension of the authorization code grant protects against. All right, yeah, and then we have our access token. So what does this access token mean? The access token is usually in the OAuth 2.0 specification, there is defined which parts are in this token. This token is, all of the communication here is JSON based. There is a, for example, expiration time. Then there's the actual access token. We'll talk about an example how such a token could look with the JWT. And then there is an optional refresh token. And again, that will also be talked about. And so you can refresh the token. But first, let's go into the part. So that was a grant used for authorization with a user. So a manual interaction, somebody needs to click, give in the Google password, for example, and then come back. So, but what about APIs, for example, machine-to-machine communication? So where there's no middleman or no user who could enter anything, that wouldn't be feasible. So there is also defined the client credentials grant in OAuth 2.0, where you're just using the client ID and secret, like you could say it's a username and password, and do that pass that exactly directly to the authorization server and get back a token directly. But that's only feasible, for example, if you don't have a web app or something where somebody could look at this client ID and secret, but a protected source, for example, API to API, like I've said, there you can safely store these credentials and not have the problem of exposing it, for example, to an end user. So that was the second grant. And then the refresh token grant is specifically designed for refreshing and expiring tokens. So it's used especially to have shorter token lifetime. So you can, for example, do a day or even an hour for the token lifetime and be able to get a new one without, that's the part, without having the user to sign in again, for example, with the Google account. because this again wouldn't be feasible, so you need to have a way to refresh. And these refresh tokens is again, the client doesn't need to understand how it's comprised, this refresh token, I mean, it just needs to store it and then send it. So, and usually the flow is the client is accessing data from the resource server, the resource server is responding, and then it doesn't respond anymore because the token, the access token it's passing for every call is expired. So there is a error code for this. The OAuth 2.0 specification defines error codes for all kinds of errors related to access. And then it knows, so the client knows, oh, it's expired, I need to get a new one, a new token, I mean. And for that, it goes back to the authorization server. Oh, here is the access token, the refresh token. Please give me a new access token. So hopefully that isn't expired. So refresh tokens usually have a long lifetime, or at least a longer lifetime than the access token. And then it gets a new access token with and that's not defined, but the recommendation here is to issue a new refresh token with the refresh. So a new refresh token is there, and also the refresh token isn't valid indefinitely. So there's a recommendation to have that expire. All right. So now we have talked about how token handling is done. So how to get tokens, and now we'll talk about the second part, JWT. So JSON Web Tokens, also it's pronounced JWT. That's specifically designed the name, so it's written there. And yeah, what's that used? So it's used for the content of the access token. The access token, like I've said before, there's no definition for it, how it is looking in the OAuth 2.0 specification, but JWT defines this. All right, so and what is a JWT? So it's a structured token format, and it's using JSON format. So everything there is JSON encoded in JSON format, and within that JSON, there are 3 parts. And I'll show a picture of an example later. And this parts, there's a payload part, and this payload part, there are claims inside. And those claims are like the name says, you're claiming something. For example, I claim this token is expiring in 1 hour. I claim I'm user ID 1, for example. So those are our claims, but anybody could claim that. And for that, there is a part to have a signature for these tokens. So the resource server getting those access tokens is able to verify that what you are saying in this payload is actually true. Yeah, and then what's also there is for the JWT, you can have it optionally encrypted. And there's an own standard for this, where there's really encryption, so the client does not even see what's inside these tokens. So they're usually, like I've said, it's in JSON format, so you can decode it, but you can encrypt it so that's not visible if you so desire. What's also an advantage for the JWT is it's a very compact format. And so it's URL encoded and base 64 URL encoded even. So it's very short and it's URL safe, so you can pass it anywhere. For example, in a parameter, there's no problem in the HTTP protocol. So no URL encoding or something is needed. And that's an advantage here. And what also the token allows, like I've said, there are claims inside those, and those claims are stored in the token. So for example, a claim could be user ID 1. And the advantage here is the server getting this token does not need to save, oh, that's, for example, the classically session-based system, where you have just a session ID, and then the data to the session ID is stored on the server side. With JWT, you can just put all the required data. I mean, you shouldn't go overboard so the token doesn't get too long, but simple data you can put inside this payload and then have the client store this. So you, the server, don't need to store anything. You're getting a token from the client and you can verify it's correct. And then you don't need to do any lookups for this data because it's already there and verified. Yeah, and so here I'll show an example of such a token. It's, like I said, in 3 parts. And there's the first part. This screenshot especially specifically is from JWT.io. So it's a nice graphical interface. You can try out tokens, so it allows to directly modify them, play around, and yeah. And a disclaimer here on this side, JWT.io is a hosted service, and if you use that and pass your actual tokens in there, be aware that, I mean, there's a disclaimer that they don't save it, so it's client-side. The calculation is client-side in your browser, but usually it's not recommended to put any sensitive data in any service you don't want to lose, like, let's say. Yeah, and then in the example here you can see there, like I said, 3 parts. The first part is the header part. There's defined the algorithms. So the algorithms on how this JSON Web Token is the signature, how the signature is defined for this JSON Web Token. And that's, for example, there are the multiple algorithms defined. There is a standard for this. It's called the JSON Web algorithms standard, and that defines all possible standards. For example, there could be more, of course, so the RFC is extended. And then there's the payload part in the JWT token. So that's actually the JWT part is actually the middle part, the payload part. And then there's the third part, that's the JWS, that is the JSON Web Signature. And that actually comprises the whole token, because the signature part is not really part of the JWT, because JWT only defines the payload part. Yeah, and then what can I, for example, here, the JWT part has claims, like I've said, and there are 7 claims defined in the original RFC for JWT tokens, for JWT. And then there's for example, the issuer claim. The issuer is like which system has issued the token. That, for example, all these claims could be then later on verified by the resource server getting those tokens, so they can know, oh yeah, there's a token, the signature matches, but I also want to do additional checks. For example, like I've said before, you can use one authorization server for multiple resource servers. So maybe they want to limit which tokens those are, and they can check those claims additionally. Other claims here, for example, the subject. So the subject is usually who this token is describing, or who is it for. For example, you could put in there your user ID and use this predefined claim name. Also the audience, that's the target. All those claims are optional. Just to say this, the audience is like who it is for. You could use this, for example, the audience could be the name of the resource server getting the token. So it knows, oh, that's for me. That's a possibility. And it's up to the implementation you're choosing, and there's no defined standard for this. And then there are some fields about dates. So the expiration time is there, the not before, and the issued at. And like the names say, they define when does the token expire, when it was issued, and when is the earliest day or date it is valid for. So for example, you could issue tokens which are only valid in the future if you so desire. And also there's the 7th claim here would be the JTI, so JWT ID claim. It can be used, for example, to give every token the authorization server is issuing. It could use this to define a ID and know, oh, this is this token. I have issued this. I know where it came from, for example. Those are possibilities for use with this claim. And then again, like in my example, you have seen there's a user ID inside there, so that's a custom claim name. And again, you can put anything in there. It's free to use. Just be aware that you don't have collisions with the existing 7 claims or any additions. So there are usually 3-letter claim names which are defined in the RFCs. All right. Then, and here a warning, I'd say. So for the header part in the JWT or JSON Web Signature, there's defined algorithms, like I've said before. And these algorithms can also be none. So the RFC defines a none algorithms. And the problem with none is here, if you have none, then the resource server checking this token thinks, oh, none, so I don't need to verify any signature. And that would be a security issue, because then no signature verification happens. Therefore, the payload is not checked, and we don't know if it's correct. So usually implementations are required. I'd say RFC doesn't require them, but it is required to discard the none algorithms and just give an error and say, oh, that's invalid because none is not something you want to use. And yeah, I would say the disclaimer that you should not roll your own crypto, so please search a package doing those parts for you. So every programming language, or most programming languages, have packages for this part, so you don't need to exactly know how to deal with them, and you can use them. Also, there are packages which do the 7 claims I've talked before. For example, the date claims, there are packages doing the validation for that, so you don't need to handle the date checks, for example. And they can be there as an additional bonus, and you don't need to think too much about them. Yeah. And then there, like I've said before, there's the JSON Web Encryption, JWT extension, which you can use to have encrypted tokens so that the payload is not visible. One thing about the JWT and the algorithms there is, for example, HMAC-based algorithms where you have a secret, and the secret would be shared. So, for example, because the authorization server issuing the token needs to have the secret to calculate the signature and pass it along to the client. And when the client passes it back to the resource server, the resource server needs to validate it. So they need to know, in this case, the secret used by the authorization server to be able to calculate the signature with the payload itself and know if it's correct. Without that, it can't verify the signature. So that's part of the flow, how it's done. And then there's for example, you can use other algorithms. Like I've said, they are defined in the JWT specification, and there you have, for example, public key algorithms, asynchron algorithms. So you have a public key and private key. The private key is only stored on the authorization server who is issuing those tokens. And then the token is issued, and then the public key is then provided to all the resource servers. All resource servers can just take this public key, do the crypto again, don't do it yourself, use a package for that, and check if the token is valid without actually knowing the private key. So what this protects against is they don't need to, so they are not able to issue tokens themselves. Because if there is a secret shared, then all resource servers could issue tokens themselves. And I've said before, resource servers and authorization servers might not be the same one. If they are the same one, then that's not really a problem. But you have a split system. For example, if you use Google on one side for the authorization side, then you have a split system, and it's not very feasible to give the access to sign new tokens or issue new tokens to our resource servers. Yeah. All right. That concludes my presentation here. I say thanks for watching, definitely, and I hope to talk again to you, and